Good morning, everybody. This is Angela Tsukiji with the North State Building Industry Association. I want to say, first of all, thank you for being a member. I appreciate your membership, keeping us engaged in the industry here in the Greater Sacramento region is really important. Taking classes like this is especially important, that you are interested in elevating your knowledge and expertise in order to do your job better. So thank you very much for being here. And thank you to Walt. He is our speaker today. But first I want to say thank you to Patty Nolan-Lento. She's our Regional Vice President for 210 Home Buyers Warranty. And she's the one that got me connected with Walt so we can do today's program. Welcome today to Misconceptions About the Common Crack. And that's a very fun title. Thank you very much, Walt, for that. Let me introduce our speaker today. Walt Keaveny is with 210 Home Buyers Warranty, and for the past 14 years, he has been the risk manager at 210 Home Buyers Warranty. Home Buyers Warranty is the national leader in new home warranties. Walt is also the underwriting manager and principal engineer at 210. He earned a bachelor's degree in geological engineering and a master's in geotechnical engineering. He is licensed as both a professional engineer and a professional geoscientist. Mr. Keaveny has over 35 years of engineering and construction experience. He is a frequent speaker and author for the National Association of Home Builders. He also serves on the Texas Association of Builders Warranty Performance Standard Review Committee. And with that said, I'd like to turn it over to you, Walt, and say thank you very much and welcome.
Well, thank you so much, Angela, for that introduction. My mother couldn't have said it any better. I appreciate that. Okay, welcome, everyone. Good morning. Thank you so much for joining us. We're excited to have you here today. I think you'll enjoy this presentation. We will be talking about the crack there on the right, not the one on the left. I think the plumbers in our industry get sort of a bum rap, so we're not going to focus on that. Keep things informal today, so please ask questions. You can ask them at any time. If you'd like, we will pause a couple of times for questions, and of course, we'll leave a time at the end for questions as well. I will also provide my email at the end if someone would like to follow up with questions after the presentation. So let's get started. Okay, let's look at a few crack facts, first of all. Okay, if there's one thing that home builders can guarantee for each and every new home, cracks will occur. Okay, we haven't seen a home yet that doesn't have a crack in it somewhere. In fact, cracks are the #1 homeowner concern when calling the warranty provider. We get over 10,000 calls a year to our warranty admin department, and cracks are the #1 concern. The vast majority of cracks, the good news, the vast majority are cosmetic cracks. They're not structural cracks, so we'll be talking about both of those types of cracks today. And lastly, it's important to point out that there's no absolute universal standard for evaluating cracks. Okay, there's someone walking up to a crack in Japan or in the United States or anywhere else doesn't have a uniform standard to decide if that's a good crack or a bad crack. So we're going to be talking about today about what methods we can use to evaluate cracks. Okay, as we look at our agenda, first of all, we're talking about what causes all these common cosmetic cracks, right? We want to know what the cause of those are so that when you're talking to your homeowners, and I know we have some engineers on the call as well, you'll be able to talk to your customer and let them know these are common cosmetic cracks, and this is probably what's causing it. Number 2, we'll look at some examples of these crack construction performance standards that I mentioned, these crack standards where there's no universal standard, but there are some standards we can use. So we'll introduce those. Number 3, we're going to learn how to plan for cracks, right? We know they're going to occur. So what can we do? What can we do to plan for it? And importantly, how can we manage that home buyer's expectation, right? Because some home buyers will just freak out when they see that first crack, and we know it's going to occur. Number 4, we'll learn to identify potential structural cracks. Now, the vast majority of cracks are cosmetic, but we do at times get structural cracks. So how do we identify those? And what are the action items we're going to take if we believe we have structural cracks? And then lastly, and very importantly, what qualifies as a structural defect, right? So when we talk about cracks and eventually talking about structural cracks, how do we know if we actually have a structural defect that a builder may be obligated to repair? Okay, now in our program nationwide, the average structural defect costs about $42,000 to investigate and repair. We have some states where it averages over $100,000 in a particular state. So these structural defects can get expensive, but there's a lot to know about what actually qualifies as a structural defect to know whether or not a builder is even obligated to address it. All right, so as we start out, we're going to talk about these causes of these common cosmetic cracks. The big one is foundation movement. Okay, that tends to be my expertise. I'm a geotechnical engineer. In our program, we find that 80% of all structural defects occur due to the foundation. Okay, and when I say due to the foundation, it's due to the soils under the foundation that are moving the foundation or allowing it to move. So 80% are due to the foundation, and 20% are due to framing. So the foundations is what's causing these problems. But right now we're just talking about cosmetic cracks. And it's important to note, first of all, that all foundations on soil will move to some degree, okay? The vast majority of foundations are built on soil. There are those foundations that are built on competent bedrock that don't move, but the vast majority of foundations are built on soil, and they will move. Everyone knows in our industry, we talk about, oh, that's normal settlement. That's common settlement. We expect that. Well, we expect that because we're building on soils. Okay, so these natural soils, they adjust to the load of the foundation, right? The foundation, let's say a typical home weighs 100 tons. When you place a 100-ton load on some natural soils, those soils have air voids in them. They have water in them. They may have some organics in them. And the bottom line is that load is going to cause some consolidation, and that foundation is going to move. And when that foundation moves, it's going to cause cosmetic cracks. Now, we don't want to forget about structural fill material. Structural fill material also adjusts to the foundation load. After all, structural fill material is essentially a soil placed by man, and even properly compacted structural fill material, if it's deep enough, will move. And if it's improperly compacted, it will move a lot. And our program, actually, structural fill material is one of the leading causes of failures of homes. So natural soils will move, structural fill will move due to the foundation load. Okay, what makes matters worse is that when we introduce water, right? The water is the builder's worst enemy. When it comes to moisture penetration into the home, or when it comes to moisture fluctuations in soil. So both natural soils and fill material will adjust as the moisture changes, the moisture content changes. And so, you know, we sell the home buyer moves in, and the first thing we tell them to do is crank up that irrigation system for a couple of weeks, right? We don't want that pretty new lawn to die. So we crank up that irrigation system, and that right away introduces a lot of water to the soil under the foundation. The other thing we do is when we place a foundation over soil, we're interrupting the natural pathway of moisture migration. So moisture migrates from the wet soil up to the atmosphere. It's always migrating upward. When we place a foundation across that natural pathway, that water starts to collect under the foundation, making it wetter. Okay, so those moisture changes, as the moisture increases, it tends to weaken soil slightly and help them consolidate. In the case of clay soils, that moisture change may actually cause those clays to swell. So we get some upward movement, some downward movement potentially with moisture changes. So that can cause cosmetic cracking. Now, it's important to note that foundations are actually designed to move, right? Our common spread footing foundations, which are the most common foundations in the country, they actually can handle up to about an inch of movement before they have excessive distress to the superstructure. And slab on grade foundations can actually be designed to move, say, 4 to 4.5 inches. So the point here is that these foundations are designed to move. They're expected to move. And when they move, that causes some amount of distortion to the superstructure above. So people think foundations aren't supposed to move. They do, and they will cause these cosmetic cracks. All right, so moisture change also causes common cosmetic cracks. Now, what do we mean by moisture changes? We talked about soil moisture changes just a minute ago, but where else do we have moisture changes? Well, how about these construction materials that we're using, right? We're adding water to these construction materials to make concrete, grout, mortar, stucco. We want to make sure we're only adding enough water to those materials per the manufacturer's instructions, okay? What happens is that we add water to these materials, and when they dry, the majority of the volume of that water leaves. And when that water leaves as they dry, it causes those materials to shrink and crack. So we've heard about shrinkage cracks. That's what causes them, is the water leaving these materials. So the higher the initial amount of water in these materials, the greater the potential for cracking. You know, the common scenario that we see is that, you know, we're getting ready to pour our foundation, that concrete truck pulls up, we take a look, and guess what? That concrete looks a little hot to us, right? It's starting to set up a little bit in the truck. So what do? We grab the hose and we start to add water to it. Well, now that concrete has a lot more water in it than it was originally designed to have. So the original concrete might have just had some hairline cracks, but now that we've added a bunch more water to it, we could potentially have larger cracks than that concrete was designed to have. So again, be careful about how much initial moisture we're adding to these materials. Okay, wood construction products. I think most people probably realize that wood has a moisture content to it. All wood products have a certain amount of moisture. Though that moisture, if the moisture leaves the wood, it causes it to shrink, and if it accumulates moisture, it causes it to expand. And so that dimensional lumber that you've ordered to come out to your home may have, just for discussion's sake, let's say 15% moisture in it. And then when you use it as for your stud walls, it may over time lose up to half of that moisture. And as the wood loses moisture, it contracts, it might contort, and as those things happen, it's going to cause cosmetic cracks on the materials that it's close to, such as the drywall. Okay, so moisture changes cause cosmetic cracks. Here's one that people aren't that familiar with, is temperature variations cause cosmetic cracks. And what do we mean by that? There are extreme temperature variations in homes, right? Particularly in the exterior walls, where the sun's shining on that wall, or in the attic. We know the extreme temperature variations in attics, okay? So every material expands and contracts, right? Expands with higher temperatures and contracts with lower temperatures. So all materials have what's called a coefficient of linear thermal expansion. And what that is, it's the potential for that particular material to expand and contract with temperature variations. And so without getting too much detail into this particular coefficient, you can just look. And you can see that the coefficient for concrete is about twice the magnitude of drywall and wood. So right away, that tells us that that concrete is going to move a magnitude almost times 2 of drywall and wood. So anytime we have concrete or concrete products close to drywall and wood products, we're going to see differential movements, and that will cause cracking. So let's take a look at an example of how that can happen in a home. We have, in this particular example, we have an outside air temperature that varies 50 degrees Fahrenheit at night to 95 degrees Fahrenheit during the day, air temperature. Well, that concrete temperature, let's say we have a concrete exposed foundation wall or footing, that concrete temperature in the sun actually gets up to about 125 degrees, right? We all walked outside on a hot day and barefoot and stepped on some concrete and know that it gets a lot hotter than the air temperature. Now, red brick is even worse, right? It's a darker color, so that red brick's going to get up to 135 degrees on a 95-degree day. So these materials are expanding a lot when they heat up to this extent. So how does that translate into actual movement? So if we take a look at this example, let's say we have a 100-foot long concrete foundation wall or footing that's exposed to the sun, and we have a 75-degree temperature differential, right? We just looked at the 125 degree for that concrete temperature when it's exposed to the sun. And at night, the air temperature gets down to 50, so we have a 75-degree temperature differential. So if we multiply that 75 degrees times that concrete coefficient, and we also multiply the 100-foot long concrete wall or foundation converted to inches, we'll get about a half an inch of movement every day that concrete experiences. And that's daily. Of course, we have seasonal changes as well, but daily that concrete's moving about a half an inch. Now, if we take a look at what happens on the inside of that wall, right? So now we have on the inside, let's say we have 100 foot of drywall on the inside of that wall, and that inside temperature is changing much less, right? The inside temperature, let's say, is 80 degrees during the day and 65 at night. So we only have a 15-degree temperature differential on the inside. So if we multiply that 15-degree times that drywall coefficient, and again, take the 100 feet, convert it to inches, and multiply that times that as well, we'll get 0.05 inches. So we can see that the magnitude of movement on the outside is a factor of 10 times the inside. And so we would expect that to cause some amount of cracking, cosmetic cracking in the home. So perfectly normal. All right, what are some other causes of these cosmetic cracks? First of all, we have wind loads, right? So we've all been in a home during a windstorm. We hear creaking and moaning. That wind is pushing on those walls and causing deflections, right? So deflections are just a fancy way of saying bending. And so wind is pushing on those walls, moving them slightly and causing these cosmetic cracks. We see a lot of that on long spans, high ceilings. We get cracking due to wind loads. Walls that have a lot of windows in them, large windows, or garage door walls with garage doors, those sorts of things, they take the wind load and they transmit it to the superstructure, and those deflections will cause cosmetic cracks. Okay, a lot of folks don't realize that there's normal deflections in joists, beams, trusses, lintels, these types of structural members. They're all actually designed to some degree to deflect and bend. Okay, the code says that these structural components are actually allowed to deflect to some degree. We don't want them to over deflect above their allowable loads, but they do deflect. And the issue we're having some problems we're seeing in our business right now is that when we have kitchens above basements, second story kitchens, that sort of thing, everybody wants that big island now in the kitchen, right? That big heavy island that's got that big slab of rock on top of it, and it creates a large load in the floor, the middle of the floor of the kitchen. Okay, so we walk into these homes now, you can put a marble on the ground and it'll roll towards the kitchen island. Okay, now that's just dead load. Now when that homeowner moves in and they have their housewarming party, what's the first thing they do is they invite all their friends and family, and everybody comes and stands where? They come stand around that kitchen island. And now we've added that live load to those floor joists as well, and causing additional deflection. And so those deflections will cause cracking in any rigid floor coverings that we have in that area. So again, it's normal, it's expected, and it causes cosmetic cracks. Okay, lastly, earthquakes. You folks in California are definitely familiar with earthquakes. I don't need to share that with you. You know, California has over 10,000 earthquakes, or some people say many more per year. Fortunately, only 2 or 3 of those probably are of sufficient magnitude to cause cracking in homes, cosmetic cracking in homes. So just be aware that these are some other things that can cause common cosmetic cracks. So I'm going to pause right here and see if anybody has any questions on cosmetic cracks before we go on.
I actually have
Okay.
a question, Walt.
Yes.
You talked about how these different materials expand, but then do they also decrease as well after they expand, or once they expand, they stay like that?
Exactly. Great question, Angela. Yes, they do. They expand and contract. Depending on what's causing it. With regard to temperature, they're going to be expanding and contracting all the time as the temperature fluctuates. With moisture, it just depends. Oftentimes, the construction materials, especially wood, will acclimate to the humidity conditions in a home. So it's different. If you take a piece of dimensional lumber with kiln dried lumber, let's say 15% moisture, and you install it at a home in Louisiana, it's probably going to swell and absorb some moisture with the high humidity there. And if you install it somewhere in Arizona, it's probably going to shrink as it loses moisture over time in the structure. So just depending on the application. But yes, they do move back and forth with temperature to some degree with moisture changes as well.
Yeah, we've had, you know, in recent weeks, we've had this heat wave as well. And then with all the fires, we've had up to 110 plus degrees out here in the Sacramento area. So we're getting affected quite a bit right now.
Absolutely. And the whole point of this is to share with everyone what causes these cosmetic cracks. They're going to occur. It gives you a little background when you're talking to that homeowner that doesn't understand it. They're not technical. It gives you a little bit of background to share with them. Normally builders just say, oh, it's normal settlement, right? It's just normal settlement. Well, there's actually quite a few more factors that are going into causing these cracks than just normal settlement. So you can have a house on bedrock, but you're not going to have normal settlement there, but you will have these other factors that are causing cosmetic cracks. Okay, so we know this cracking is going to occur. We know this movement is going to occur. So there are different types of construction joints that help us to prevent and control the cracking. Now you builders out there, I don't need to share with you. You all are using these to some degree, but I can tell you a common problem in our industry is that we get homeowners filing structural claims. We send an engineer out there, and they see this, jagged, step tapered cracks in brick. They see the hairline cracks in stucco, and the homeowner thinks that there's a huge structural defect with the home. Well, we all know that those cladding materials carry no structural load at all. However, we didn't allow, or the builder didn't allow in these cases for these materials to expand and contract. As I showed earlier, that red brick gets really hot, 135 degrees, and when it's 95-degree air temperature, and you get this half-inch or more expansion daily. And so we want to place expansion joints, in those materials, because if that movement and that cracking occurs in a designated, nicely aligned joint, the homeowner's not going to notice it, and your phone's not going to be ringing. So we want to use these. We have control joints in concrete. We have expansion joints in cladding materials. Slip joints sometimes can be used in roof trusses. We have problems with what we call truss uplift in the attic, where the bottom of the truss is in the insulation and it's close to the warm ceiling of the room below, so it's nice and dry and nice and warm. The upper part of the truss is cooler, and it's maybe in more humid conditions, and that truss is going to move, and if it's structurally attached to the underlying walls, it's going to cause cosmetic cracking in ceilings. And so that's an application for a slip joint. There are crack isolation membranes that we're aware of, below rigid flooring, so we don't have reflective cracking when we have some of those movements in floor joists. So I know you all are familiar with these different types. I'm just encouraging you to use them to the extent possible. There are guidelines in the code. There are guidelines in various industry standard publications for different construction materials to how to place these. Okay. Okay, for some reason my screen has frozen.
I can always try to jump in and put it up on my screen.
Can you give me control again? Because I got a little message a minute ago, Angela, that my video control stopped or something, and so I don't know if
okay.
If that's something that happened on your end.
Let me redo that. Yeah. Sorry, everybody.
That's okay. We'll be right back. And
okay, how's that? Can you get back?
I'm going to stop share and then try to restart. Well, Angela, for some reason it's frozen.
Okay, let me go ahead and do my screen.
Yeah, maybe you could take over for me. I'm not sure what's going on there.
Yeah.
Hey, Walt, I have a question in the meantime. I'm no engineer or anything. But how do post-tension cables versus, you know, like rebar and things like that affect the cracking?
I'm sorry, I missed the question. The difference between post-tension and rebar?
Yeah, how do they affect, you know, the cracking? Is one crack more than the other?
Yeah, it's a good question. So, you know, the post-tension foundations are considered to be the best the best slab foundations, because those post-tension cables allow the movement, which is typically differential, right? So we don't normally get movement across the entire foundation. We get movement in one corner or one side of the home. And those post-tension cables allow that movement to be distributed more uniformly over a larger area of the foundation. So therefore it causes less racking and distress of the foundation above it. So I would say the post-tension foundation is a little better to cause less differential movement. The rebar foundations are good as well, but not as good as post-tension. But they both can be designed to handle several inches of movement. And when a foundation moves several inches, you know, quite frankly, it's going to cause a certain amount of cracking above, cosmetic cracking. So yeah, good question.
Okay, is the screen showing okay, everybody?
Okay, Angela, you're showing the screen now?
Right.
Are you taking over? Okay.
Yeah.
Good.
Does it look
All right.
okay? Okay.
Yes, it looks fine. Yeah.
Okay.
So we can go on to the next slide, please. Good. Okay. Thank you. I apologize for that. I'm not sure why we froze over there, but in any case, this is an important topic, establishing construction performance standards. Okay. Builders may not realize it, but builders, even if you don't think you're providing a warranty to your homeowner, you are. Every state in the country has what's called an implied warranty. And that implied warranty has with it what's called a construction quality standard of good and workmanlike construction. Okay, so you are providing a warranty. The term varies nationwide from 6 to 10 years. So even though you may be telling your homeowner you're giving them just a 1-year soup to nuts warranty, in fact, you're giving them a greater term than that, than 1 year. And so the key to that is to replace that implied warranty with what we call an express warranty. So the law allows you to replace that implied warranty with a written express warranty as long as it's reasonable and as long as your homeowner agrees to it in advance. Okay, so that's important. And so you can do that in different ways. But the key component of that express written warranty is that it identifies the construction performance standards by which you're going to judge the quality of your construction. Okay, because if you don't identify those, the standard becomes good and workmanlike. Okay, so let's say a homeowner calls you up and they've got that first drywall crack, and they're going to call you up and you're going to go out there and take a look at it with them. So you walk up to that crack and the homeowner says, you know, look at this. I've got a structural problem with this home. And of course, you've just learned all of the different reasons that these cosmetic cracks occur. So you're sharing those with the homeowner, and the homeowner says, no, I'm not buying it. I want this repaired. I've got a structural problem here. And so the argument becomes, is it good and workmanlike? The homeowner feels like it is not good and workmanlike, and you say it is. Well, that's what leads to these disputes. Okay, the court systems nationwide are chock full of disputes. There are different states that have or are mandating a warranty for every home. Every new home because of these disputes. And so we want to avoid them. So in this express warranty that you're going to provide, you then can replace this standard of good and workmanlike with an actual construction performance standard. And that means that you now have a measurable, defensible standard that you and the homeowner agreed to, and this will avoid disputes. Very important. So we'll talk about some of those coming up next. Okay. Another component of construction performance standards is, again, defining what qualifies as a structural defect, right? We have cosmetic cracks, we might have structural cracks, but ultimately, if there's a qualifying structural defect, that's where things get expensive. And so we want to define that ahead of time as well. Next slide, please, Angela.
Is that?
Okay. Okay. Yeah, this is fine. So we're going to talk about some examples of crack construction performance standards. Angela, the next, there you go. The first one is if you have a third-party warranty company, they will have construction performance standards in their packages. So those, our warranty booklet, for example, has 40 pages of standards. And so when the homeowner gets their certificate of warranty, they get that booklet. If the homeowner has a problem, they will call into the warranty administration department, and they will walk them through the standard that applies to them in the booklet. And so that's important to have. Now, if you don't have a third-party warranty, the National Association of Home Builders puts out a residential construction performance guidelines. They update these every couple of years, and the third-party warranty companies, to some degree, mirror those. And here are some examples of crack widths in those NAHB standards. And so we see at the bottom there, we see drywall. The standard there is in the first year workmanship. If that drywall crack exceeds the 1/16 of an inch, the builder in this case would be obligated to repair that. So there they are. So they're measurable. You can look at these with the homeowner, and you can say, listen, it either meets or it doesn't. I'm obligated to repair it or I'm not. And that's the important part. This is what we want instead of good and workmanlike. Okay. And then the last standard there is an engineering standard. These workmanship standards that I've described earlier tend to be for the first year workmanship period. But engineers are called out to homes, sometimes many, many years after the home is sold. And engineers tend to use a standard such as this. And you can see here an engineer is going to think, based on this standard, that a severe crack is going to be something over about 1/2 inch over the lifetime of that home before we're going to get pretty concerned. Next slide, please, Angela.
Walt, may I ask a question in regards to the previous slide with the numbers? Is that a national average? Does it vary based upon particular location where, the soils might have, a tendency for greater movement, or as you were saying, the fill dirt is used more prevalently, so therefore there might be differing allowances for the size of the cracks?
It's a good question. Yeah, it does make sense, because you are right. There are parts of the country that are much higher risk for cracking than others. Okay, there are parts of the country where people use more fill material. There are parts of the country where there's more expansive clay, where these foundations are going to move a lot more than other parts. However, the standard for those cracks are consistent across the country. So the National Association of Home Builders puts out their guidance, and it is intended to be a nationwide standard. Same with the third-party warranty companies. They apply that standard uniformly across the country. So you're right that there's a higher potential for cracking in some parts of the country than others. However, the homeowner expectations for what is a reasonable crack and what isn't, what should be repaired and what isn't, is consistent across the country. Thank you for that question. All right, so now it's important to manage our homeowner expectations, right? So, and you're doing this in other parts of your business, builders are, but it's particularly important here. So we've decided what construction performance standard we're going to use, and again, we're going to get the home buyer to agree to that as early in the process as possible, typically at the contract phase. So the homeowner agrees to that, and now we've got established what is going to be a crack that we're going to be obligated to repair or not to repair. Okay. Another part of managing homeowner expectations is to explain to them that these cracks are common. All the things we're talking about here, they're cosmetic and they're common, and sealing of those cracks or repairing those cracks are considered routine maintenance, right? There's routine maintenance along with touching up the paint, the caulk, the grout, all these things. Basically, you're going to take care of them for the first year, but after that, you're going to encourage them to hire a handyman every couple of years and do this routine maintenance. This is considered routine maintenance. And number three, the way to really drive that point home is to provide them a home maintenance guide, right? If you provide them a home maintenance guide and you turn to the page that talks about, how drywall cracks are common and considered routine maintenance, it drives that point home. You could even take it a step further if you want to and provide some general guidelines on how to repair that crack in their concrete driveway, or how to repair that drywall crack if you want to take it that far. Okay.
Well, Walt, do you mind if I ask another question?
Please, it's a good time to pause right now.
Okay. With some of those good practices for helping to advise the new homeowners that here's some ways to take care of that. Have you seen home builders who have come up with some kind of like multimedia kit where, you know, not almost like a do-it-yourself kit where, you know, here's some videos ahead of time, so that way they're I guess providing kind of the full gamut. You know, we're not just selling you this house, but, you know, here's ways to help with the routine maintenance of it.
You know, I haven't seen builders use video. In our program, we do have a homeowners guide that we provide homeowners, and I know builders out there have their own guides as well. There are engineering firms that have their own guides in terms of, you know, what homeowners should do, number one, to avoid cracks, right? For example, you know, maintaining that grade around a home and not creating any ponding next to the foundation, maintaining your gutters, all those things. So there are various guides out there. I think your suggestion for video is terrific, right? We're all moving towards video these days, and we don't have it yet. We are considering doing videos that homeowners could reach on our website, and I think it'd be a great idea for builders to consider doing that as well. But as of yet, I don't know of any builders that are using videos in that capacity.
Can you tell Val's background is in marketing?
Aha! That makes a lot of sense.
Yeah,
that makes a lot of sense.
But it makes sense in terms of, you know, how often are you hearing people say, well, I just, you know, I watched a YouTube video on it and I figured out how to do it. So anyway.
No, and that's probably, and I haven't thought about that, but yeah, you could probably go onto YouTube today and find a video on how to repair a crack in your driveway. That's probably, or in your drywall. It's probably there now, but whether or not, you know, builders have that, I haven't run across that yet.
Okay.
So
Thank you.
Good suggestion though. Good suggestion.
Thanks.
Okay, so we've talked about all these cosmetic cracks and how common they are and what's causing them, and we've talked about some things you can do to avoid cracks, or at least keep them under control, make them something the homeowner doesn't see. We've talked about setting homeowner expectations and establishing construction performance standards. So these are all very important things when it comes to cosmetic cracks. But lo and behold, sometimes we get structural cracks, and we need to kind of understand you know, what constitutes a structural crack, and worse yet, what if that is related to a qualifying structural defect. So let's take a look at structural cracks. These are some indications. First of all, as we mentioned earlier, a crack that's, you know, maybe exceeds about 1/2 inch in size should start to get you concerned that there may be a structural issue with the home. Number two, excessive floor deflection or tilt. We're going to talk much more about that in a couple of slides. If the floors are deflecting, or as we said, another word for deflection is bending, or tilting. By tilt, we mean that the entire house is tilting from one edge of the house to the other, right? We see that commonly when homes are built on deep fill material, and that fill material, that entire mass of fill material is moving uniformly, moving the home uniformly. We see this tilt. So if there are excessive floor deflections and tilt, that's a concern, and we'll talk more about what excessive means in a couple of slides. Number three, inoperable doors and windows, right? As that foundation moves and it moves the superstructure above it, that superstructure starts to rack, and when it does, it starts to confine the function of doors and windows, and so they start to not work so well, or they stop working. That's an indication there could be a structural defect, and it's quite important, because if in the case of a fire egress issue, we want to make sure doors and windows are working. Number four, excessive wall surface slopes, bowing, or leaning. So if you go out to that home, the homeowner calls you out there, you're going to bring your measuring tape, you're going to bring your level. It's important to know whether or not that wall out of plumb, out of level, if those things are as-built conditions, or do they reflect movement of the foundation, right? So when we're talking about warranties and structural defects, we're talking about things caused, you know, after you've sold the home and movement that's occurring after you've sold the home. And so it's important to bring your level. And if you go out there and you notice that the floor seems to be uneven, we put your level on the floor and it's uneven. However, you put your level on the countertop and it's level. Now you're looking at likely an as-built condition, right? That floor, that slab, let's say, was poured on level, and that's okay, right? That's not a problem because it's not indicative of post-construction movement. But your finishes are level, and so that's likely not structural movement going on in that case. Okay. Number 5 is cracks with the. I'm sorry, Angela, can you sneak back to that one? Thank you. Number 5 is cracks with displacement. So we talked about some of these things that cause cracking, such as drying of materials like concrete, or expansion contraction with temperature. Those types of cracks open up typically in a common flat plane, okay, where the crack is opening up and it's staying level. However, if one side of the crack displaces with regard to the other side of the crack, so one side is higher or lower, let's say, than the other side, that could be indicative of some forces that are not normal and that may be indicative of a structural problem going on. Okay, and lastly, homes with basements, horizontal cracks are a concern, right? So in a basement, when you have a basement, let's say poured concrete wall, that basement wall is going to be longer than it is tall. And so we expect that shrinkage cracking in that concrete to occur the lengthwise, majority of it in the lengthwise dimension of that wall, and that causes a vertical crack when that concrete shrinks. So vertical cracks in concrete basement walls are considered normal, okay? But when we see a horizontal crack, that's likely caused by the soils on the outside pushing in a horizontal manner on that wall. Now that starts to concern us, especially if that wall is bowing or leaning with that load on the outside. So those are some indications of potential structural cracks. Next slide, please. Okay, so now we maybe suspect some structural cracks, right? We've looked at this, we've gone on visited the homeowner, we suspect some structural cracks. So what do? Okay, so the first thing we want to do if we have a third-party warranty is call the warranty company and ask for the experts there to assist you. If they believe that it is a structural situation, they will send out an independent local state licensed professional engineer to look at it and collect data. If you don't have a third-party warranty company, that's fine. You are going to call your own qualified professional engineer at that point to come out and look at it as well. Either way, we're going to get an engineer to set eyes on that. Okay, the engineer is going to measure all the cracks, the length, the width, the displacement. They're going to photograph those cracks, and the engineer should, it's getting to be a standard, it is for us, the engineer should do a floor elevation survey, right? And so this is a topographic survey of the floors in the home. It's similar to what we know of topo surveys outside on land, but we're doing this in the home now because we are trying to determine how much that foundation is moving and deflecting and tilting. Okay, and so typically the engineer will go in and they'll take a shot on a 10-foot grid in the home, and they'll collect that data. We'll ultimately produce a 3D diagram with it, and we'll look at how the home is deflecting. Is just one corner of the home deflecting and the rest isn't? Is the whole home tilting from one side to the other? What's the magnitude of the deflection? Is there more than one type of deflection? So these floor elevation surveys are critical to evaluate whether there is a qualifying structural defect. Okay, so all that data then is very useful because we're going to go use it, as we'll talk about next. We'll use it to determine if there's a qualifying structural defect. If not, we're going to be able to go to that homeowner and give them some comfort that we've sent a professional engineer to your site. The engineer has collected all of this data, and lo and behold, right now, the movement in this house does not qualify as a structural defect. However, keep an eye on it. Let us know if in a year or two it continues to move. We now have the data as a baseline so that if you call us back in a year or two and you think things have gotten worse, we can send the engineer back out and we have all this information and we can determine whether things have gotten worse or not and whether it now qualifies as a structural defect. So this is the importance of collecting that floor elevation data. Next slide, please. Okay, so here's what this boils down to. You know, we've talked about cosmetic cracks, we've talked about structural cracks, but ultimately, as I mentioned, the expensive part of this potentially for the builder is if it qualifies as a structural defect. Well, we need, first of all, to have a construction performance standard for whether or not it qualifies as a structural defect. We need to define this ahead of time and have the home buyer agree to this, preferably at contract stage. Okay, so what I've listed here is 3 different standards that are used in the country, and I'm going to share with you why I believe the first 2 are too vague, and the last one is one that we like. Okay, so let's look at the first one. It's the HUD standard. So I think it's been around since the longest, probably since 1980 or so. And HUD developed this standard because for government-backed loans, HUD didn't want to be stuck with homes with structural failures. And so for a period of time, they mandated warranties for these homes, and they wanted to develop a standard for that. What defines a structural defect? And unfortunately, being the government, they came up with a very vague definition. If we look at just those last few words that are bolded there, unsafe, unsanitary, or otherwise unlivable is their standard. Now that's pretty vague. I think we'd all agree that without those terms being defined, we really don't know. That would definitely lead to a dispute. Unsafe, for example, would be some sort of a structural member that is overloaded, appears to be over deflected, and that would define unsafe. Now, we don't see very much of that. There's a fair amount of redundancy in framing design. We don't see a whole lot of unsafe conditions, so we don't use that oftentimes to adjust claims. Unsanitary is a very unique situation where the structural member in that case would be the foundation, and you might have your waste discharge pipe running through the foundation. The foundation deflects, moves considerably enough to cause a break in that pipe, causing an unsanitary condition. Again, we don't see that very often, so those 2 are rare. The vast majority of claims are adjusted under what's called otherwise unlivable. Okay, but what does that mean, right? These terms are not defined. You know, when you in a dispute with your homeowner, the homeowner is going to hire their engineer, and you've got your engineer, and you each hire your attorneys. Everyone's going to have a different definition of unlivable. You know, one person is going to consider unlivable. There's one window that's not working in the house, and they have you know, a countertop that might not be perfectly level, and another person might consider unlivable, you know, a situation where, you know, you've got a massive tilt. So it can just vary greatly. So we in our program have defined unlivable. I'll talk about that more in a moment. But this government definition, unfortunately, still leads to a lot of disputes. And this is what was used for many years nationwide. New Jersey, which is the second definition there, is the bold words at the bottom there say vitally affects the use of the home for residential purposes. Okay, what does that mean? You know, again, that's just as vague as unlivable. There's no definition for that. And so there's not a black and white objective standard. And so again, we don't care for that definition very much in our practice. So the third definition, however, is the one that we like. This is a standard that was developed in Texas back in 2004. Again, the courts were chock full of construction dispute cases in Texas, and they tried to find a solution. The builders there actually were behind it in developing a solution, and they developed what's called the Texas Residential Construction Commission, and they mandated that every new home in Texas have a new home warranty on it to avoid these disputes. And they solicited the help of the American Society of Civil Engineers to help them come up with the standard for what qualifies as a structural defect. And being engineers, they came up with an engineering standard, a code-based standard that has worked really well in Texas, and we like it. It has 2 parts to it. The first part is the deflection component. The deflection shall not exceed what they call L/360. So let's not get too carried away with the technicalities of that. That's a code-based standard of how much the floor or structural member is allowed to deflect or bend. Simply what that means is about 1 inch and 30 feet. Okay, about 1 inch and 30 feet of deflection in a floor system is going to qualify, if more greater than that, qualify as a structural defect. And so the way we come up with that is the L in the L over 360 is the length over which the deflection is occurring. And so let's just say, for discussion purposes, that's 30 feet. So if we take that 30 feet and we convert it to inches, it's 360 inches. So L is 360, we divide it by 360, we get 1 inch. 1 inch is the allowable deflection over 30 feet. If we had 60 feet, we would convert that to inches, that'd be 720, divided by 360 would be 2 inches. So you'd have 2 inches of allowable deflection over 60 feet. So this is the standard that's easy to understand. Keep in mind it's post-construction movement. We're looking at the amount of movement that happens after, not an as-built condition, but post-construction, because we want to see that the foundation is actually moving. So the first part of this definition is this deflection, which, just keep in mind, is about 1 inch and 30 feet is a good rule of thumb to use there. Okay. The second part of the definition is tilt. And so by tilt, we mean a uniform movement of the entire foundation from one end of the home to the other. So for easy understanding's sake, if the house is 100 feet wide and one edge of the home is a foot higher or lower than the other, 1 foot being the 1% tilt, 1% of the 100 feet. If it's 1 foot higher or lower on one end of the home than the other, it's going to exceed the tilt definition. So these are black and white, defensible, measurable standards. When the homeowner hires their engineer in a dispute and the builder hires their engineer in a dispute, and they conduct the floor elevation survey, they're both going to agree on whether or not it exceeds these standards or not. So it does not lead to dispute and does not lead to litigation for that reason. So any questions on qualifying structural defects? This, by the way, the third one is the one that we're using nationwide now. So even though in some areas they're still using the HUD definition, we're defining unlivable in our program by that Texas standard that I just mentioned. By the way, the TRCC in Texas, the commission that mandated the warranty, sunsetted several years later. I think they decided that agency didn't have enough teeth in Texas. But in any case, the builders in Texas love this standard so much, they used it for several years, that the Texas Association of Builders embraced it. And I serve on a committee for the Texas Association of Builders that evaluates their construction performance standards every couple of years and updates them. And this is the standard they like there. And again, this is the standard we're using nationwide to avoid disputes. Next slide, please. Okay, so to summarize then, we have some best practices. Okay, first of all, we're going to avoid those construction practices that cause cracks, right? We're going to not add too much water to our mixtures. We're going to protect the wood from moisture fluctuations when it arrives at the site, those types of things. Okay, number two, we're going to plan for cracks with construction joints. We're going to use those as much as possible, because if the crack is not unsightly, if it cracks where it's supposed to, then the homeowner isn't upset and the homeowner will not be calling you up. Okay, number three, we're going to establish these construction performance standards, right? Because if we don't, then we default to good and workmanlike, and that's too vague. That leads to disputes. So we want to establish some sort of a construction performance standard. And again, you're welcome to use refer to the NAHB standards in your contracts if that's useful to you. Number four, we want to manage those home buyer expectations. The more we can convince them up front that you're going to be using these construction performance standards. These cracks are normal. They're going to see them. Here's your homeowner maintenance guide on what you can do. That really helps temper and manage homeowner expectations. And lastly, in cases when we do have structural cracks, and we really want to pull in an expert for that. It's really not something that a builder can tackle on their own. You really want to pull in a professional engineer, take those measurements, look at those deflections and tilts, and determine whether or not you have a qualifying structural defect. Next slide, please. Okay, before I open it up for questions, I just want to mention that this link here will take you to an article with the same name as this presentation. It's an article that was distributed by the National Association of Home Builders nationwide. It's been one of our more popular articles. We have builders that have posted it on their websites. We have builders that include it in every closing package. And again, because they want to temper and manage those home buyer expectations by having them read this article and see that these things are common. This is what causes these common cosmetic cracks. So you can download the article from this link. There's lots of other articles there I think that you'll find useful and user-friendly. And again, my email address is there if anybody wants to follow up with any questions. So with that, I think we have a minute or two left. I'll open it up to any other questions.
This is Patty. It's not a question, it's just a comment about, in California, we have SB 800, which is our right to repair law. And there are certain guidelines provided in that law as to how, you know, how long something's supposed to be warranted. But most builders understand how it works now because it's been in effect since 2003. But the key is to remember that even in SB 800, and I have one of those fun little SB 800 booklets, even in SB 800, it doesn't provide the definitions like what Walt was talking about, clear and concise, and you know what they're supposed to do to maintain their home, what's actually a defined issue and what's not. I mean, it doesn't get into the details. So I just want to reiterate, you know, over the past 17 years, SB 800 builders have learned they have to be very specific about what's warranted, what's not, to what extent, or you're still going to be in dispute. So I just always want to reiterate, SB 800 wasn't the end all be all, but it does at least shorten the statute of limitations on certain things, but you still have to be very concise in your defining of warrantable and not warrantable items. So I just want to throw that out in case anybody had a question about how this relates to SB 800.
Thank you, Patty.
Thank you all.
Yes. Any other questions or comments? No? Well,
Just
yes,
a
Val.
comment to Walt. You can definitely tell you enjoy your job a lot. Great information presented really well. So thank you for your time and going through this.
Thank you so much, Val. Thank you for your questions.
Yeah, I really appreciate the time that you gave us today, Walt. I wish we had some new home sales agents in on this call. That's definitely a target audience that we should have included. And so for the builders that are on the call, you might want to pass on this information to your new home sales agents as well as your own teams.
And Angela, I understand you'll be sharing a PDF of this presentation with everyone, correct?
Yes, I already have, actually, yes.
Oh, terrific, terrific, okay. Well, I want to thank you for hosting us. It was a pleasure. And again, if anybody has any follow-up questions, just reach out to me by email.
Yes, thank you very much for sharing. We appreciate it.